Welcome to the next video in the Systems Programming video series discussing Chapter 7, this time 7.3 of the Dive into Systems textbook. And we'll be looking at a few arithmetic instructions this time. They are mostly pretty sensible and, we don't even really need that many of them. You're free to read that over, but it's pretty straightforward. There's bit shifting. In previous videos, we've talked about arithmetic and logical bit shifting. We previously didn't see that there was any difference between arithmetic and logical bit shifting to the left. So honestly, I'm not terribly sure what this distinction is here. I could look it up. I'm not even sure that there is a distinction there, but we do know this distinction already. Then there are bitwise operations like the and, or, XOR, not. I think this is all really evident, especially based on everything that we've already discussed. So this might be the shortest video of all. Oh, there is this, okay, so we will talk about this at least a little bit. Load effective address instruction. So its command is LEA, and it is used as a fast way to compute the address of a location in memory. So it is very similar to previous things, but it does not subsequently do a memory lookup. So to do a little walkthrough, let's imagine that RAX contains the value 5, RDX contains 4, RCX contains 808. And it turns out, in this example, we'll imagine that 808 is itself an address. So if we did LEA 8 paren the RAX register, RAX, then all this does, in a sense, it seems like it's basically just kind of overriding the idea that when there are parens, you're doing a memory lookup, right? So all we do is the sort of predictable 8 plus RAX, but instead of doing any memory lookup, we simply store it in RAX, okay? Using the paren notation, we simply sum these two things together, but again, rather than doing a memory lookup, we simply store it in the second argument, which is RAX. This does a multiplication, again, just like the memory syntax, except that we don't do the memory lookup. So, I don't know, is that hard? That doesn't seem that hard.